Hey everybody, just trying to make sure that the stream is actually working for people. If you would, please go to the Discord and enter the Patreon live stream channel. It's a 30-second delay over the live here, so it's much easier to chat in the Patreon channel over on Discord. be on shortly. I'm posting some links to the stream to various places. Okay, for all of you that are in the live stream, if you would please go into the Discord chat in the Patreon live streams chat room and let me know how you can hear me and let me know how the video is looking. I want to make sure everything is working fine. I'm going to sit here and wait for a couple of minutes until I can see if people start typing and let me know how you guys can hear. Sounds good? All right. Nice and clear? Can you guys see well at the same time? All right, so welcome to part 2 of my soldering classes. This is going to be based on through-hole, and we're going to go through, I'm going to try to keep it to right about an hour. And we're going to go through the basics of through-hole soldering. And I'm going to actually do some live soldering here for you. Show you a little bit of tips, some tricks on how to do it, and the proper techniques and procedures. So what we have here in front is, don't freak out. It's a pretty dead 500 plus. I'm not doing anything that's going to be unreversible on this thing. Eventually I'm going to transfer it over to another board. But most of the stuff on here is not in very good shape to begin with. So we're going to use it to do a little demonstration. As you can see, I have some various components that I've taken off the board, and we're going to put them on. So just going through some of the basics, talking about some of the different things. Through-hole soldering is still commonly used. Surface mount is by far the most current and widespread used now. But through-hole has its place. It's where a lot of people like to start. In my personal opinion, I think through-hole is more difficult than surface mount, but surface mount does take a little bit more of finesse and proper technique to get it to go easy. So most people think that through hole is easier to start with, and that's where they pick it up at. So this is where we're going to begin, since it's the most common and most understood. So what you see on here in the board, if you notice here, I have a socket. Yes, it's a broken socket, but we are going to go ahead and show the first technique of putting a socket onto the board. And the way that this goes is you want to make sure that you have a nice clean work area. So we're going to go ahead and pull out some Q-tips for that, and some isopropyl alcohol. So the first step that we're going to do here is clean up the area where this socket will go on, and this is going to be a ROM socket. You can see it's going to go into this area right here. So I'm just going to clean it up with some alcohol on the top here. That's just going to get any oils from your fingers out, any dirt, any kind of other impurities that are on the board. You don't need to really worry about drying it, you just do it. So when you're putting on the socket, one of the things that you need to really pay attention to is the direction that your socket goes. So if you look on a socket, you can see that there's a little notch right here on the top. So the little notch indicates usually where pin 1 would be located at. And if you notice, you can see on the board here, we do have a pin 1 up in the upper left-hand corner. This being a sort of special 500, it has a longer socket like the 1200 does, and the 600. So you want to make sure that you line this socket up properly. So in the case of this one, it is a big socket, so it covers everything. Now when you're putting a ROM in on this particular one, you need to pay attention to as well. The little arrows here that show back mean that you're skipping this first set of pins, and you're going to start on the back here. If you were, say, putting a smaller socket on here, and you had no intention on using a larger ROM chip, you would actually back it up once like so and solder it on. Either way will work. But in this case, this is a full-size socket for this board, so we're going to go ahead and put it on. So you're going to want to place the socket in place. Now a lot of people ask, well, how are you going to hold it in? Because if you flip it over, it's going to fall out. What I like to use is Capcom tape. Pretty simple stuff. It's not very expensive. It's easy to come by. And the reason that you use this is it's heat resistant, so as you're soldering, you don't have to worry about it falling off. So just for the sake of teaching here, we'll just use a quick, easy one piece of it. Make it nice and tight, and you want to get it close to the edges. Just place it on, and keeps it from falling off. Pretty simple. And again, we are on Discord. If anybody wants to type any questions or if they see anything, since there is a delay over the live stream, the easiest place to do that is through the Discord chat. Alright, so flip the board over, because through hole soldering, if I didn't mention it earlier, and again, for those of you that know how to do some soldering and are just watching this, I'm going to keep this very basic and very simple. And if I say some silly stuff or things, it's all part of the fun. So, through hole soldering is traditionally done on the bottom side of the board, obviously. Component side and the solder side. So we'll flip this over and we'll get to the solder side. Now, one of the important things about through-hole soldering, and any soldering in general, is you want to have the board work for you. don't work for the board. And what I mean by that is you need this to be comfortable. So what you can do is adjust the board so that it is in a comfortable position for yourself. Don't like try to bend your arms and your hands in weird positions. So in the case of this board, I'm going to put it like so. And the reason that I do it this way is I like to sort of work at an angle here as it goes up. So there's a couple of things that people need to do as far as soldering. Since this is a demonstration, I'm going to show both ways here. Some people like to use flux, some people don't like to use flux. It all depends upon how good your equipment is and the solder you're using. The solder that I'm using is rosin core solder, which means it does have a core of flux in the center of the solder, but it doesn't always necessarily mean that it's going to solder well without external flux added to it. So what you're going to do is you're going to use your iron. Now you don't touch the solder to the iron, even though it melts. You want to touch your solder to your work and the iron on the other side. So you're going to heat, apply solder, release the iron. It's very important that you're not trying to feed solder into the hot iron itself. If you do that, you're going to create what's called a cold solder joint. And a cold solder joint is basically the solder is just melted on top of the board and it doesn't necessarily join with what you're soldering. So it creates basically a bad connection. And you want to avoid that. And the way that you avoid a lot of that is by using flux, or you do proper techniques. So again, place your iron onto the pin. Let me actually see if I can get this into view of the microscope view. There you go. So you want to place your iron onto the pin that you're getting ready to solder. Let it heat itself up. And then opposite of it, you're going to put it on and feed the solder in. And then release. A good solder joint, if you can see in the view, is nice and shiny. And you want it shouldn't be dull. So let me try to show you a bad example of a solder joint where you put it on and you want to and you touch onto here. So it's kind of hard to see, but that's not a very good joint. It's not smooth. It's bumpy on the top there. It's just you want to make sure that you're feeding into the joint, not into the thing. So you can redo it, add a little bit more solder, and pull away. Again, so you notice you want to keep your iron clean. And the way that I'm doing it is I'm keeping a nice angle here. You know, right about a 45-degree angle. And if you notice my tip is a chisel tip. So I'm placing it onto the pad itself, which is, in this case, it's an eyelet or a hole, and the pin together, touching them together. And then I'm adding solder to the pin on the opposite side of my iron, joining them together, and then releasing it. And you get a nice, clean, shiny joint. Okay, so what we'll do is we'll go onto the opposite side over here, and I'll solder the opposite side so that you can get a good view of, you know, holding it down steady. Because remember, the only thing we have holding this thing down right now is the Capcom tape. We don't want to do that. The Captain tape is good, but I would rather have a solder connection holding the chip down. Alright, so we have a couple of soldering points done here now, as you can see. So what we'll do is we'll flip it over real fast. And this is just what we're checking for, to make sure that it is good and solid. We want to make sure that we don't have any, it's not loose. Seems like this side is up in the air a little bit, so you want to be careful with that. So what we're going to do is I'm going to move this tape, and I am going to place it on the other side here. And we're going to flip it back around again and continue on. This time I'm going to add flux to show you the difference between a flux connection and a non-flux connection. So we will start at the side that I have the tape on so that it holds more solid. So I'm just going to add some flux to a couple of these on the side here, and we'll leave the opposite side without any flux on it, just so you can see the difference of what soldering is like with flux and without flux. So I am trying to center under the microscope. I am working off screen. So there we go. It should be a little bit better. Okay, so as I said, this side over here is going to has flux. This side over here does not have flux. So we'll see what the difference is. So the same technique. Feed it, take it away, release. Again, you're looking for a nice smooth joint. You're touching the solder pad or the eyelet in this case, and the pin of the socket that we're soldering with the iron to heat them together. And then you're feeding the solder in across from it, not touching the iron directly. You're touching your work to be soldered. So again, you can see that on the third. Feeding it in, release. And you're looking for nice, shiny solder joints. So what you do is you go a little bit quicker, and you can kind of see how to go and feed. A nice, steady motion here. You want to keep your iron clean and just keep feeding it in. And I'm keeping my iron at approximately, it's about a 45-degree angle, I would say. Kind of so that the chisel tip is flat against both pieces. And you want to make sure that you're not over soldering. And the way that you can kind of tell that is just that comes with time. You can kind of look at some of the other things around that'll give you a tip on it. Too much solder is just as bad as too little solder. So what you're doing is you're just trying to make like a little dome, sort of a volcano. It's kind of hard to see, but I can you can zoom in a little bit more at the end here so you can kind of get an idea. Okay, so we got the side over here with flux, and again, flux makes a mess, so the best way to clean up after is you want to use I use a Chemtech wipe, and it's basically kind of a tissue paper type material, and alcohol. The best way to do it is, believe it or not, you place your Chem wipe directly onto your surface, apply some alcohol, and you want to clean right through the top of the wipe. And what that's going to do is it's going to wick that flux away from the board and just help to clean it up some. All right, and as you can see, we missed a spot, so I will add some more. Okay, so we have one whole side here that's been soldered. And I can bring it up a little bit closer so that you can get an idea of how things look in the microscope here. It's kind of tough to see. But what we're looking for are nice shiny solder domes. No blobs of solder everywhere. My temperature is 750 degrees Fahrenheit on my pencil. That's right about where I like to work. For leaded solder, it works very well. It seems to be a good temperature. Temperature is just as important as your technique. You want to make sure that your solder flow is just as good as not flowing enough. And what I mean by that, if you're too cold, it's going to blob up and it's not going to flow easily. If you're too hot, you're going to risk the danger of burning. So you kind of have to find your happy medium, and it's different per iron. I use Hacko gear, so 750 seems to be perfect for me on it. And again, that was with flux on one side, and we'll go ahead and do the opposite side. And you'll notice my solder as well. I'm not using a giant thing of solder. So we can actually change it a little bit. And I'll show you the difference between using solder that is larger than what you really need. So this one, this is, I'm not sure what gauge. This is 23 gauge or 0.025. I believe this is 0.012. Let me see. So this is 0.015, the one that I was just using. And this other one, like I said, is 0.025. So you can see the difference, and when I put it into the microscope area here, you can see how this is quite a bit larger than this one. And the way that you basically would use it is, if you're soldering something big, say like a power connector or a larger footprint item, you're going to want to use larger solder. For finer stuff, you're going to want to use smaller gauge solder. The reason of that is it's going to add too much solder in if you have a giant thing of soldered. So I'm actually going to show you that here in a sec. We'll switch over to this larger one and show you just how much more difficult it is to solder on a socket with a big one. So again, centering up into the microscope shot for y'all, and we will solder onto the other side here. Now if you notice how much larger this bead was compared to the other ones, and sure, you can pop it on here like so, and I mean, look, it's even on my iron, it's still on there quite a bit. I mean, you can just use less and go, like so. However, in my opinion, I think that's just it's a waste. You don't need to do it, and it's not as precise. And you don't know if you're getting a good joint because you're blobbing it all in. It's like turning on a faucet on full blast. So I prefer the smaller gauge just so that I can actually see the hole being filled with the solder as I'm filling it, instead of it just all flowing in immediately at once. And again, just nice and steady. Feed opposite of the iron. You're not using the iron to melt the solder directly into the hole, you're using your work, and I'm actually touching the pin that I'm soldering to on the opposite side of the iron. So the pin is flat. I have the iron on one half of the pin and the pad, and the solder is being touched to the opposite side of the pin, and that is what the heat that is melting, not the iron directly touching the solder. That's very important. Again, when I use this rosin core solder for something like this, you don't necessarily need to use flux for it. Again, you go in a nice steady pace. We got some nice clean joints. Okay, so I saw a question about the difference between flux remover and IPA for cleaning purposes. So basically the difference is, and I just so happen to have some deflux here as well, it's just what's in it. So I have contact, well, this is contact cleaner wash, so I actually thought I had some defluxer, but this is still quite similar. So the biggest difference between IPA and defluxer is defluxer has a lot of other chemicals in it. A big chunk of what's in it is acetone, and it happens to break the flux down a little easier. Me personally, I don't really need it because I ultrasonic clean everything, and it has some material in there, and what I use is organic as well, so it's helpful for the environment. But it breaks the flux down and takes it off. You've seen my boards when I do it. It's super clean. But the biggest difference is what's in it. So example, so this contact and board wash is, its main ingredient is, let's see, I don't even know what the heck this is. Isohexane. It's got ethanol in it, which is alcohol basically. Ethanol is not as healthy as isopropyl, but it's the same. And it also has some sort of propellant in it because this is a spray. That's the biggest difference, is what is the ingredients in it. And you can look up and make some homemade defluxers and stuff. IPA doesn't work very well for just getting flux off. It will still be there. You have to use a lot of it, which is why I like to use my cleaner, my ultrasonic, is it'll strip everything out. So restricted in California. I don't know which one is restricted in California. I missed what you said. So I'll show you what I use. This is what I use in my ultrasonic cleaner. It's Bramson, and it's Bramson EC, which is electronic cleaner. So kind of give you a little view here of what I use. This stuff is pretty darn good. It's expensive, so this one, what is this? I think it's a quart size. It only uses 103 milliliters to about 1.25 liters, 1.25 liters of water. And the way that I have it written down here is I use 103 milliliters to 1 gallon. So it lasts quite a while. And I keep my ultrasonic cleaner half full, and it's a 30 liter. So it'll last, and I can get about 10-15 washes out of it. And that is going to be another topic. We are here for soldering. So again, that was doing a socket. So as you can see, we got both sides of the socket done. It's completed. We've cleaned it up. Kind of hard to see. Like I said, it's off camera for me, so I don't know how well the video is showing up. zoom in a little bit and see. So yeah, it actually shows up okay. But you can see all my joints are nice and shiny. You do see some flux on there from the solder. Again, that'll get cleaned off afterwards. And on the other side, what we're looking for again now is a nice solid flush to the board. We'll remove the tape again, pull it off, and now we have a good new socket on here, although it's broken. Again, this is a board that I'm doing just for demonstration purposes. Okay, so that's how we do a socket. So how about a component? So components, again, you need to pay attention what kind of components that you're soldering, and the technique is just the same. The only difference is you want to place a component where your component needs to go. So we'll go ahead and do a capacitor, because a lot of us see capacitors as something that gets done quite often. Again, if you'll look on the board, you'll notice here, so we're going to go ahead and put these two capacitors back into the circuit, and what we're looking for is the positive side and the negative side, because capacitors are, for the most part, are directional. You need to know what side is positive and what side is negative. And the way that you find that out, let me pull out a new capacitor here. Okay, so here is a brand new capacitor. It has not been soldered in yet or clipped. And here is one that I removed earlier that has been clipped. So one of the questions is people say, well, how do I know what side is positive or negative? So on a new one, the way that you can tell the positive side is the leg will be longer. So if you notice on here, this leg here is longer than the bottom leg. That is your positive leg. So that goes on your positive side. On the board, you'll notice right here, you have a plus right there, and you have nothing on the other side. So your longer leg will go into the plus. Another way that you can tell is by looking on the can itself. If you look here, you have this stripe on one side and nothing on the other. And if you notice on this one, you also have a similar stripe and nothing on the other. And if you notice, that stripe is on the shorter side. So in almost all cases on these types of capacitors, these are radial capacitors, the stripe will indicate your negative side. So if you're putting in one that's been clipped, that's how you can tell the difference. Now, depending upon whether you want to clip or not clip, the capacitor is completely up to the person putting it in. I leave them long, but since this is a capacitor I pulled out earlier, I'm going to go ahead and put it back in with both sides clipped. So again, you're just going to place it on the board the same way that you did the chip, with both legs going in through your holes. Make sure that you do the positive side to positive and the negative side to negative. Flip the board back over again. And in this case, since the legs are not there any longer, we're going to have to do something to keep it from falling out. Let's try to find it. Okay, so just like before, we are going to heat with the iron on one side and apply solder to the opposite side of it. So you can see our capacitor right here. Same thing, touch one side, heat it up, and on the opposite side, I'm going to add the solder. Let it flow, remove, and you have a nice joint. Then you're going to go over to the opposite side and do the same thing. So I'm touching my iron to the pad and to the leg of the capacitor. I'm going to heat my iron up. So here's a good example of needing some flux. And the reason that is this is the ground or the negative side, and it takes quite a bit of heat to do it. Some through-hole stuff is a little trickier than others, and if you've seen me do my live recaps, I almost always put flux on these to begin with because they're a real pain in the butt. So add some flux. It's easy to clean it off. Get your iron back out again. Same thing, heat it up. And there we go. We got a nice, clean, shiny joint. You can notice, and I will take the Q-tip and I will clean it up so you can get an idea of how it looks after it's been cleaned. So we have nice clean solder joints. And flipping it back over again, we can inspect it. Make sure it's nice and flat. Level to, it's not too loose. It's on nice and tight. We're good to go. So we'll go ahead and add our second one just the same way. And if you can look here, we got the same one right here. You can see the positive and the negative indicators. And again, I've got my capacitor, the stripe indicating negative. So right here. And this time I'm going to apply flux to both of these. You see how much easier it is when you have flux on there. No fighting. Nice solid joint. So tap just a hair bit more. And a little bit of alcohol to clean it up. Make sure that we actually do have good solid joints, and we do. So that is a capacitor. Again, I have left another section here loose. If you look, these have been soldered, these have not. They actually were soldered, but I used a vacuum tool to take it out. And the reason that I did that is I wanted to show you guys a little bit about using larger solder for bigger pin pattern as you're soldering. And remember I said using smaller stuff on a bigger one is just kind of, it's a pain in the butt. So you notice how big this pad is compared to this piece of solder. So if you watch, I mean, it does work. It works just fine. You can put it on. The thing is I'm having to add a ton of solder, as you can see. And I get a nice little dome. Again, like I said, that's what you're looking for. Is you want a nice even dome. Not a big giant blob. But it took quite a bit of solder. Now if I take out the larger stuff, again, I've got my iron on there and touching the pin. that is where the difference comes in of using the right gauge solder for the job. As you can see how much quicker that went than having to use the small one. So we'll do that again. There you go. Same technique, same angle, just a larger piece of solder. And again, when you're doing this, you want your tools to do the work for you. You don't want to fight with your tools. So using the proper tool for the job is extremely important in this. I'm going over to the chat real fast here. So now I'm going to show doing a pin header. So this being a Amiga 500, a lot of people are wondering, where's the expansion port at? Well, it's here in my hand. So this is just as easy as any other soldering. You're going to want to line up your pin header. Get it into position. Now in some cases you might need to use some Captain tape or something similar again to hold it in place. Or in this case it fits pretty solid in here. You want to make sure that it's nice and level. Go ahead and flip it back over again. Again, you want to place the board in a position that it works for you and you're not struggling or fighting with it. I like to use a smaller gauge for this, even though it's a little bit bigger than the chip socket is. And the same kind of thing here. Now the way that I like to do pin headers is, these are extremely important to keep straight because, you know, expansion cards are going to be plugged into these. So you want to start on the extreme end, heat it up, feed some solder in, let it go. Make sure that it's still in position properly, and then go to the opposite side and opposite pin. In this case, this is a 2-row header, so I want to make sure that I'm doing this corner, and then I'm going to come down and do the opposite corner on this side to lock it into place. So as you can see now, it's nice and tight, locked into place. It's straight the way that it needs to be, and I'm not going to have to worry about it falling off as I'm soldering. Now, some people will actually go through and do the centers as well. I do that on larger ones like this, but it's up to you. As long as you have both sides secured, it's going to be relatively good to go. So now I have it in 3 spots, and I'm going to just pick a side. Again, clean your tip up. And if you notice, this again, this is a chisel tip, so touch your work, add some solder, and move on. On these, you want to be careful. This is one of those areas where you need to make sure that you're not overheating, because if you do, you're going to melt the plastic that's holding these pins in place, and it's going to cause a bad connection on your expansion when you plug it in. And the way that you do that, the way that I do that is I'll do a couple on one side, then I'll come back to the opposite side again, give the other side a chance to cool down some. Just feed the solder in. Keeping enough slack so that you can feed without running out. Again, remember, iron is touching the pin and the pad at the same time, and I'm feeding opposite and trying to basically fill the hole and make a little pyramid sort of shaped dome on here. You don't want to add too much, otherwise you can create solder bridges. You don't want the two sides to connect. You're just trying to make a good connection through the hole and through the top of the pin through itself without putting so much solder on that it just looks sloppy and it's a mess. And again, this comes with time on how it should be, and you can look at other things around to kind of get an idea. You'll get a good feel for it as you go. I like to keep my iron clean, as I said. Just work your way down to the end. Then I will start on this side again and just feed my way down. Another tip that I like to do is on some of these larger through holes is you can actually notice that you can actually get the edge of your soldering iron into the hole a little bit, and it just kind of helps lock it in place, and it ensures that you're getting a good temperature range through the entire thing as the solder melts. That way you know you're avoiding any cold solder joints. Just keep adding it in. Feeding it through. Trying to keep a nice uniform amount of solder throughout the entire project that you're doing. Not over soldering or not under soldering. And again, that comes with time. That's why you want to practice on an old scrap board or something. Just kind of get that feel of how it should look and how you can feed. Make sure you keep enough solder going so you don't burn your fingers. And again, I'm going to say it over and over again. I am not touching my soldering iron with the solder to melt it directly. I am touching the pin on the opposite side and feeding the solder in so that it forms around the pin and makes a good clean connection. There we go. Now that is back on nice and solid. It's clean. We can use the toothbrush, like I said, to clean it up. And I'm just using an old soft bristled toothbrush. Again, you're looking for nice shiny connections. Kimtech wipes, get the old stuff off. There we go. That header is back in place. You can flip it over and we'll make sure that it's nice and flat and still level. You notice we've got a couple of bent pins. That's just because this thing is an old dead board. Straighten them up. Check it, make sure everything is good, and it does look good. There we go. So you would do the same thing with any through hole item. The technique is similar. You're going to apply your iron, give it a second to heat up, apply a feed to the opposite direction, just good enough until you get going. The same thing would be with like this Agnes chip. We're not gonna solder the Agnes chip socket on here, but again, some other tips to pay attention to when you're soldering is the direction of it. So if you look on here, you can see an arrow. If you look on the board, you have pin 1 right here. The arrow points to pin 1. That's almost always the case on every chip. In some cases, you have the little notches, like I had mentioned before, on these memory chips. There's a notch on the top here. You can see the notch on these where there is no chips. That's how you would tell the direction that these chips would go in. And you put them in the same way, and you solder them the same way. So now I'm going to show a little bit about desoldering through-hole components, because that is something you're going to end up doing down the road when you repair. Alright, again, like I said, I'm 30 seconds out, so I just saw a question. So yes, you can buy soldering syringes separately. I've got a big giant box of them. You can do that. Again, or you can just use without it if you want, but you can't buy the needles. I have a big bag of needles someplace. If you look on eBay, you can find them. You can also find them on Mauser. You can also find them on DigiKey, and they come in a big, wide range of sizes. Like I said, I've got a big bag of them somewhere. Let me see. You can see here is my bag of syringes, or needles, I mean, and I've got several different sizes here that you can look at. And these go on the same way the caps do on the syringes. They just lock in place. So, again, as I said, often you're going to need to desolder things just as much as solder things as for through-hole. There's a couple of ways that you can do that, and there's a couple of different tools that you can use to do that. The most basic is using a solder sucker or a desoldering tool, such as one of these here. And the way that this works is there's a plunger. You push it down, it locks into place. You push the button, the plunger pops out, and it creates a vacuum on the opposite side here, and literally sucks the solder right off the board. Now you want to have some flux when you're doing this. It makes things a lot easier. So we'll go ahead and we'll find a thing. So let's see. We put these two capacitors here on earlier. Let's go ahead and take them off using one of these. And then while we're waiting, I'll go ahead and turn on my vacuum desoldering tool, my electric one with the gun, and we'll show you the way to do it with that if you have one. But again, you don't need expensive tools to do this stuff. You can do it simply with, these things are only like $5 or $6. They're not bad. So I like to use flux. You want to put it on. Don't be shy about it. You can put a good amount of it on. Charge it. So let's see. Hopefully this is in camera. We'll move it up. There we go. Center it. Again, I'm going to use my iron. And this works just like soldering does. You kind of want to have it on the opposite side of your iron. You want to get it ready right away because it's not going to wait for you. Put it on. Get the solder nice and molten. And this is a silicone on the end of this so that it's heat resistant. Put this right on and if you can look, it's out. Do the same thing. Recharge it. Pop it on there. Heat it up good. And it's loose. Go ahead and add a little bit more flux. Add some more solder to this again. So you probably caught on to that. That wasn't the capacitor. The capacitor is right here. So let's go ahead and take this capacitor out again. Pop this on. Charge it. Let's get this back up so you can see. And heat it up to solder. And I'm not a fan of using these things, but like I said, it does work. Then you will take some solder braid. Because you're going to see a good example of why I hate through-hole and why I love my soldering guns. This is going to be a fail. Traditionally, it does work fairly well on sometimes. We'll try it on something else. Let's see. You get the idea of it, though. Now I'm going to do it with my soldering gun, which is way easier. I don't even want to deal with this anymore. So I've actually showed people a few times. Since we had a fail with the previous one, you don't want to try to use your soldering gun over and over and over again on a failure, because all you're going to do is end up burning up your board. So you want to add fresh solder. Give the capacitor a little wiggle. You can feel that it's loose. I'm adding fresh solder, like I said. Give it a little bit of wiggle until you feel that it's loose. You want to take your soldering gun. I'm going to try and get this in view for you. And you're not shoving it on to touch the board, you're just touching enough for the solder. And out it comes. Much quicker, much easier. So I had a question about my take on tacky flux versus liquid flux. I've got both. I like tacky flux myself, just because the brand that I use is Amtech, and it works really well, and you get what you pay for as far as it goes. So this is one of the more popular ones that I prefer to use, the NC559. Very good stuff. It melts easy. Nice car going by, big truck. The liquid stuff works really well as far as like for doing through hole stuff and things. You can use it in pens and you can use it in different things. There's different versions. There's rosin based versions of it and there's rosin free versions of it. Here's an example of some of my an older Weller that was rosin based that I no longer it's empty now. For the most part, though, I prefer the taggy stuff, just because it works really well. It stays in place and it doesn't evaporate quickly. The rosin stuff is also a lot messier, and it's just you have to get it off. If you don't get it off, it will eat your board up eventually. And it's just the cleanup is much easier on the tacky stuff. All right, so that is a quick rundown for this week's through hole. If anybody had any other questions, again, we're live in the Discord. I'll stay in the Discord for a little bit, but I just wanted to show a little bit about through hole soldering and the basics of how it works. Next week's plan is to do some surface mount soldering to show the difference, and I'll use flux, and I'll show you where tacky flux really comes in handy for that. And that will be not this coming Saturday, but the following Saturday. So every other Saturday is how these classes are going to work out. So before we leave, I'm going to go ahead and solder on this other capacitor back into its place, because eventually I am going to have this board fixed again. Use some of the old flux that was left over. Soldering gun temp, I have mine set, since it's very quick. I don't know if you can see the temperature range in here. Let me see if I can get it on, and let's see. So you can kind of see a temperature range on here. Goes all the way from 350 degrees Celsius at the low end to 500 at the high end. And I have mine right now set at right in between 3 and 4. So I guess that would be 425-ish Celsius. So right about the same, about 800 or so. You got to be careful with this thing, though. I really recommend you practice with a desoldering gun before you just start going to town on and taking things off thinking that it's easy, because you can really destroy some solder holes with a desoldering gun if you're not sure what it is that you're doing. So definitely practice. And the key with the desoldering gun is you're not touching the board, you're touching the pin, and you want to give it just a little bit of a wiggle and vacuum it out, and then keep holding the gun down and then release it, and then let go of your trigger, and it should clear the hole. If the hole isn't cleared on the first try, you don't go back and try again. You add more solder and then try again to take out the new solder. So right around 800, 825 or so is what my soldering gun is set at. And again, that's so that it's quick. The whole point is you want that solder to flow and not clog your nozzle up. And very important with these is to use a clearing pin. So this is a point 0.8 millimeter nozzle, and this is a 0.8 millimeter wire. And I'm gonna clean. I purge out the connection, and then run it again to keep it clean. Alright, we'll stick around in the chat for a little while and talk. But thanks for watching. I hope that this was worthwhile. If you can give some more tips or advice on things that you'd like to see done, we can go live and we can do that. And I can show you in the future on how to do that specific task. If you have any recommendations for other videos that you'd like to see in the Patreon, please go ahead and comment in this class. I'll leave it in, and we will go over that as well. Again, week after next will be basic surface mount soldering. Again, I'm trying to keep these things to right about an hour, and we went over a little bit. But I will continue to do these, and we'll go a little bit more advanced. And my goal in the end is to hopefully do a live stream of building a bare board all the way up to maybe whole. We'll figure that out, though. Thanks again, and we will see you soon.